Good afternoon, my name is Aaron Silva and I'll be introducing the topic of rate of reactions. What is a rate of reaction? So the rate of a chemical reaction is defined as a change in concentration of a reactant or product over the change in time. So we express the rate of a chemical reaction in molars per second. We have one reactant A turning into product B. Time is equal to 0. And the initial concentration of A is 1 molar, and A hasn't turned into B yet, since time is equal to 0. That'll also explain why our initial concentration of B is 0. Now, after waiting for 2 seconds, we measure the concentration of A, which turns out to be 0.98 molar. So that means we lost 0.02 molar for the concentration of A. And the final concentration of B is 0.02 molar because that's how much it gains in 2 seconds. So in order to find out the average rate of reaction, we need to plug in the rate of equation, which is change in concentration over change in time. Now let's find the average rate of a reaction of the appearance of B, which is our product. So the formula we're using is final concentration minus initial concentration all over final time minus initial time. So our final concentration of B, which is 0.02 molar, minus our initial concentration, which is 0, all over our final time, which is 2 seconds, minus our initial time, which is 0 seconds. Our answer would be 0.01 molar per second. Now let's find our rate of reaction of the disappearance of A, and the answer should be the same. So our final concentration for A is 0.98 minus our initial concentration, which is 1 molar, all over our final time, 2 seconds, minus our initial time, which is 0 seconds. Our answer would be negative 0.02 over 2, but that would give us a negative rate of reaction because negative divided by the positive number is going to give us a negative. So we would have to put a negative sign because in chemistry, the rate of reaction is defined as a positive quantity. Now we will get the same answer we got as before, which will be 0.01 molar per second. We calculated the average rate of reaction using the disappearance of A and the formation of B. And we could say that the rate is equal to the change of concentration of A over change in time. But we have to put a negative in front of that in order to make it a positive value. And all this would be equal to the change of concentration of B over change in time. Now, there are 2 different ways to express the rate of reaction. Here's a practice problem of a balanced equation of dinitrogen pentoxide into nitrogen dioxide and oxygen. So oxygen forms at a rate of 9 times 10 to the negative 6 molar per second. So what is the rate of formation of nitrogen dioxide? So basically, for every mole of oxygen is created, 4 moles of nitrogen dioxide form. So we just multiply the number by 4, meaning that nitrogen dioxide forms at 4 times the rate of oxygen. So NO2 is equal to 9.0 times 10 to the negative 6, all multiplied by 4. And that'll equal to positive 3.6 times 10 to the negative 5 molar per second. Now what about dinitrogen pentoxide? What is the rate of dinitrogen pentoxide? So for every mole of oxygen that forms, we're losing 2 moles of dinitrogen pentoxide. So we just multiply the number by 2. And since we're losing dinitrogen pentoxide, we put a negative sign next to the answer. So 9.0 times 10 to the negative 6, all multiplied by 2, is equal to negative 1.8 times 10 to the negative 5 molar per second. So dinitrogen pentoxide disappears at twice the rate that oxygen appears. So our rate is equal to 9.0 times 10 to the negative 6. And the rate is also equal to the change of the concentration of oxygen all over the change in time. Now what about nitrogen dioxide? The formation of nitrogen dioxide is 3.6 times 10 to the negative 5. And what number do I need to multiply it in order to get the number to the left? Well, since 3.6 times 10 to the negative 5 is 4 times bigger than the number to the left, I need to multiply it by 1/4. So the change in the concentration of nitrogen dioxide over change in time has to be multiplied by 1/4, because when you do this side, you do the same thing to the other side. Now what about dinitrogen pentoxide? So dinitrogen pentoxide is negative 1.8 times 10 to the negative 5. And what number do I need to multiply that in order to get the original number? So in terms of magnitude, I need to multiply it by 1/2. But it's a negative since we're losing dinitrogen pentoxide. So I need to add a negative here in order to make it positive. So the change of dinitrogen pentoxide over change of time. Now I need to do the same thing to the other side. So negative 1/2. Now all of these are balanced because they are all equal to 9 times 10 to the negative 6. So now we have all of our reaction rates of each part of the balance equation, and they are equal to each other. So here's another practice problem of a balance equation of ammonia into nitrogen and hydrogen. So for every mole of nitrogen, 3 moles of hydrogen is being formed. That means I would need to multiply 8 times 10 to the negative 6 times 3. That is because every time nitrogen is being formed, that'll be 8 times 10 to the negative 6. And when that forms, 3 moles of hydrogen is also being formed. So I need to multiply that by 3. And that'll give me positive 2.4 times 10 to the negative 5 molar per second. Now what about ammonia? NH3. So there are 2 moles of ammonia that is disappearing when nitrogen and hydrogen is being formed. So I would need to multiply 8.0 times 10 to the negative 6 times 2. But since it's disappearing, it has to be a negative. So a negative 1.6 times 10 to the negative 5 molar per second. And this is just equals to positive 8.0 times 10 to the negative 6 molar per second. So our rate is 8.0 times 10 to the negative 6, and this is the rate of nitrogen. So for the change of concentration of nitrogen over the change in time. Now for hydrogen, the rate of reaction of hydrogen is 2.4 times 10 to the negative 5. Now what number do I need to multiply this in order to get the same rate of reaction as nitrogen. I need to multiply this by 1/3 because originally the number was multiplied by 3. So I just need to do the opposite and multiply it by 1/3. So we bring down the 1/3, multiply by the change of concentration of hydrogen all over the change in time. And for ammonia, that is negative 1.6 times 10 to the negative 5. So we multiply this by 2. So we need to do the opposite, which is 1/2. But we need to multiply it with a negative 1/2 because we cannot have a negative rate of reaction, because rate of reactions are defined as positive quantities. So that means that we bring down the 1/2 times the change of concentration of ammonia and H3 all over the change in time. So that is our answer. That is our balance equation for each of these elements. And here is a different problem. So it is carbon disulfide, and is converted into carbon and sulfur. So sulfur is being formed at 4 times 10 to the negative 5 molar per second. So for every mole of sulfur is created, 4 moles of carbon is formed at the same time. So it is being created 4 times more than sulfur. So carbon is equal to 4.0 times 10 to the negative 5, all multiplied by 4. And that'll give me 1.6, positive 1.6 times 10 to the negative 4 molar per second. Now for carbon disulfide, this is disulfide. So for carbon disulfide, that is 4 times 4.0 times 10 to the negative 5, because there's a 4 here. So 4.0 times 10 to the negative 5 times 4. Since that is being converted into these elements, it'll be a negative. So it'll be negative 1.6 times 10 to the negative 4 molar per second. Now our rate of reaction is 4.0 times 10 to the negative 5. That is a rate of change in concentration of sulfur over the change in time. Now for carbon, that is 1.6 times 10 to the negative 4. We multiplied it by 4 previously, so we multiply it by 1/4. And that'll give us 4.0 times 10 to the negative 5, which will make them equal. So 1/4 times the change of concentration of carbon is equal, oh no, not equal, the change of concentration of carbon over the change of time. I forgot to put the 8 here. So for carbon disulfide, that is negative 1.6 times 10 to the negative 4. Now we multiply this by 4, so it'll be 1/4 too, but we need to put a negative 1/4 because it's the same reason, can be negative. So we bring down negative 1/4 times change of concentration of carbon disulfide over the change of concentration, or no, change of time. And that is our answer of our balanced equations. So here's another practice problem of finding the average rate of reactions. So here's one there's a balanced equation of zinc sulfide into zinc and sulfur. So sulfur is, the rate of formation of sulfur is 12 times 10 to the negative 6 molar per second. Now, for every mole of sulfur, 1 mole of zinc is created. But the thing is, there are no coefficients in front of these elements. So that means we don't need to multiply the original rate of formation with the coefficient, since it's 1. 1 times 1 is 1. So that means this will stay as positive 12 times 10 to the negative 6 molar per second. It will stay the same. But in this case, for zinc sulfide, it is losing moles and is being converted into zinc and sulfur. So it will always be negative. So negative 12 times 10 to the negative 6 molar per second, because it's losing. Now for the rate is 12 times 10 to the negative 6, and that is equal to the change of concentration of sulfur over the change of time. And since there's nothing to be multiplied with, so 12 times 10 to the negative 6 stays the same. So the change of concentration of zinc over the change of time. But zinc sulfide is negative 12 times 10 to the negative 6. And we need to get rid of the negative. So we just bring a negative 1. Multiply this by negative 1. That'll give us a positive rate of reaction. So the change on negative 1 times the change of concentration of zinc sulfide over change of time. And that is our answer for zinc sulfide into zinc and sulfur. Now this is our last problem. So water is being converted into hydrogen and oxygen. So the rate of formation of oxygen is 5.0 times 10 to the negative 3 molar per second. So there's a coefficient here, so that means we need to multiply them by 2. So for every mole of oxygen, 2 moles of hydrogens are being formed as well. So 5.0 times 10 to the negative 3, all multiplied by 2. And that'll give us positive 10 times 10 to the negative 3 molar per second. Now for water, H2O, the coefficient is also 2. So that means 2 moles of water is being lost, is being converted into 2H2 plus O2. So that means it'll be negative 5.0 times 10 to the negative 3 times 2. And that'll equal to negative 10 times 10 to the negative 3 molar per second. Now for the rate of reaction, that is 5.0 times 10 to the negative 3. And for this one is change of concentration of oxygen, O2, over the change of time. Now for hydrogen, that is 10 times 10 to the negative 3. I need to multiply it by number to give me this number. So I'll use 1/2 since I multiplied by 2. So 1/2 times the change of concentration of hydrogen over change of concentration, change of time. Now for water, that is negative 10 times 10 to the negative 3. And you multiply this by negative 1/2 because of the same reason, no negatives, only positives. So negative 1/2 times the change of concentration of water, H2O, all over change of time. And that is our answer for our final problem. And that is my project for introduction of reaction rates.